Hi, so now in this video we're going to start solving circuits, which means finding the currents everywhere in a circuit. Um, now, there are two approaches, one that we'll see later on, which is more general, but the first approach works only in certain cases. For some circuits, it is possible to simplify by combining resistors in series or in parallel. I want to mention again that this does not always work. There are some circuits for which it's impossible to combine anything in series or in parallel. Then we'll have to learn a new technique for those circuits. But for now, let's look at a simpler case. Okay. Um, Now, just to remind you, you know that if you have several resistors in series, you can replace them by an equivalent resistance whose value is just the sum of the resistors. If you have several resistors in parallel, then you have this equation that gives the equivalent resistance as in terms of the resistance of each resistor that we're combining. If you take this equation here, you might have seen the equation written in this form. To solve for R equivalent, I have to take the inverse of this side, so I have to take the inverse of the other side too. So that gives us this equation. R equivalent is equal to 1 over R1 plus 1 over R2 and so on, all that to the minus 1. Okay, so that's one way to write the equation. Okay, now, before we can use this approach, we have to be able to tell by looking at a circuit if two resistors are in series or in parallel. You can have cases that are very simple, like here. This is a very, very simple circuit. Everybody can tell right away that those two resistors are in series, so you can combine them by adding them. And we can tell also that those two resistors are in parallel. It's obvious, the way it's drawn is obvious. So you can replace them by an equivalent resistance. After you've replaced those two by an equivalent resistor, the resulting resistor here are equivalent would be in series with this one, and then you can keep combining like that until you have only one resistor in your circuit. Now, that's very easy in this case, but sometimes you can draw a circuit where it's not that obvious if two resistors are in series or in parallel. So we're going to look at marginal cases. Okay, just to make things more specific here, look at this circuit. We have a battery here, and there's those 5 resistors. Now, the way they're shown here, uh, it might not be obvious which ones are well, again, it might be that no resistors are in series or in parallel, then you cannot combine anything. But here we can combine everything. So the first thing is to ask, well, can we tell right away if two resistors are in series? Let's start with that, okay? So can we tell if two resistors are in series? Now, the general rule is this. But by definition first, what do we mean by two resistors being in series? By the way, I use the word resistors here, but the rule applies to any circuit elements. I could talk about batteries in series or anything else in series, capacitors in series, and so on. But let's just use the term resistors for now. How to tell if two resistors are in series? By definition, what we mean by resistors being in series, they are in series if the same current flows through both of them. That's the definition. Okay, but just by the definition here, that doesn't tell us how to tell if two resistors are in series. So how to tell? Well, then from what you know about branches, then it's pretty clear. Two resistors are in series if they are in the same branch, because you know that in a given branch, the current is the same everywhere in that branch. So if two resistors are in the same branch, they are in series. Okay, another way to tell the same thing, if you're at ease with branches, then this definition here makes it really crystal clear out to whether two resistors are in series. Another way of checking, which you might prefer or not, it's up to you. But another way of checking is just to check the following fact: two resistors in series if it's possible to go from one end of the first resistor. Doesn't matter which end. You pick one. Is it possible to go from one of the two ends of the first resistor to one of the ends of the second resistor without crossing a junction? So you start from one side of one resistor, you try to go through the circuit and go to one end of the other resistor. If you can do that without going through a junction, they are in series. By the way, just to emphasize, I didn't mention anything about other circuit elements. You have to go from the first one end from one resistor to one end of the other resistor without going through a junction. It's totally fine to go through another circuit element. So if you go through a third resistor or you go through a battery or anything else, it's okay. As long as you don't go through a junction, the resistors will be in series. Okay, so let's apply that. In this circuit, again, first, if you work with branches, you must be able to identify the branches. So how many branches are there here, and where are they? Well, it should be clear that there are 6 different branches. So here you have one branch going from here, here, all the way here. This is my first branch, okay? Then there is a branch here from there to there. That's the second branch. You have a third branch here, a fourth one here, a fifth one here, and then the sixth one here. Okay, so there are 6 different branches, therefore 6 different currents. So the question is, are there any 2 resistors that are in the same branch? Then it's obvious. R5 and R1 are in the same branch. Therefore, they're in series. Okay, let's apply the other definition just as practice. Well, remember the other definition is, can I go from one end of that resistor to one end of that resistor without going through a junction? The answer is yes. I can go from this end here, I go here and there, and I went to the other resistor without going through a junction. Notice I went through the battery, but that doesn't matter. As long as you can go from one end to another end of the 2 resistors without going through a junction, they are in series. So R1 and R5 are in series. You can combine them. You know when they're in series, you just add the values. So they can be replaced by those 2 here, R1 and R5, can be replaced by R equivalent equal to 14 ohms. Okay, so R1 and R5 are in series, so replace them by, and I call R15 the equivalent resistance coming from combining R1 and R5, and it's 14 ohms. Now I have to redraw the circuit. So the rule is, when you replace 2 resistors in series by an equivalent resistance that I call R15, all you do is that you replace one of the 2. You could replace R1 by R15, or you can replace R5 by R15. And then the other resistor that you did not replace, you just replace by an ideal wire. So let's say we'll replace R5 by R15. So I'm going to replace R5 by R15. That will become a resistor of 14 ohms. And R1 here we replace by an ideal wire. So it gives us this circuit. Yeah, and this is a general rule. When we replace 2 resistors in series by an equivalent resistance, we replace one of the 2 resistors by R equivalent, and we replace the second resistor by an ideal wire. By the way, if you were combining, let's say, 3 resistors in series, or 4 of them, all you do is that you replace one of the resistors by R equivalent, and you replace all the others by wires. So we've simplified the circuit to be this. Now the next question is, can we simplify it further? Well, if you look at that, so you check again, are there any 2 resistors in series? No, because all the resistors, this one, this one, this one, and R15, they are all in different branches. So we cannot simplify further this way. Then the next question is, are there 2 resistors in parallel here? If so, then we can combine them. So the answer here is yes, there are resistors in parallel, but we'll do that in the next video, okay? So we'll pick it up in video 12. We'll talk about how to simplify resistors in parallel and how to tell if 2 resistors are in parallel. Okay, thank you.